This is Carol Hollingsworth. I want to thank you again, thank all of you for joining us today. As we dig into, starting with this specific webcast, as we dig into the applications of some of these products, they're going to be quite interesting, and hopefully they're going to be very helpful to each of you. I am the JPS Vice President of Sales, Iggy Bragato, the JPS Senior Sales Engineer. We'll be providing you with today's presentation. We really appreciate your being with us today. Today's presentation is on the RSP-Z2 Dual Channel Gateway and some standalone applications for the RSP-Z2. Iggy will discuss the RSP-Z2 as a standalone dual channel gateway that can operate without a network or server to support remote unattended applications. Now, the real reason you're here today, let me turn the program over to Iggy Bragato. Iggy?
All right, Carol, thanks again. Appreciate that. And I'd like to welcome everybody to the JPS Interoperability Solutions Weekly Products Briefing webcast. I'm Iggy Bragato, Senior Sales Engineer, and as you know, we also have here with us is Carol Hollingsworth, our Vice President of Sales. And in this week's webcast, we're going to discuss various standalone applications for the RSP-Z2 Dual Channel Gateway. And a few weeks ago, we conducted an RSP-Z2 Dual Channel Gateway webcast, and subsequent webcasts such as the Z2 controller and the MCC4 multi-channel desktop console webcasts, the RSP-Z2 Gateway was really an important part of those discussions as well. So in those cases, the RSP-Z2 can be a very important component in large distributed communication systems that we plan to discuss in the future. The RSP-Z2 can also be used effectively in small standalone applications. That's what we're going to discuss today. So let's have a quick review of the RSP-Z2 Dual Channel Gateway. And each of the RSP-Z2 channels can be provisioned to support an LMR system by using attached donor radios. And today we'll see lots of applications that utilize donor radios. The channels can alternatively support several digital protocols such as JPS RoIP, as well as standards-based protocols such as RTP and SIP, as well as push-to-talk over cellular applications and even USB headsets. So one nice attribute of the RSP-Z2 is that it doesn't require the use of a server or a controller to operate in isolation, meaning that the RSP-Z2 does not need to be attached to the network. Although the RSP-Z2 can be managed by the Z2 controller or even the ACU Z1, it's not necessary for small capacity or even tactical deployment. So, however, today we'll certainly discuss applications that do utilize network connectivity for specifically unattended backhaul solutions. And these backhaul capabilities, again, include JPS RoIP, JPS bridging channels, RTP SIP, and many of the push-to-talk over cellular solutions on the market. Several of our webcasts featured some sort of distributed communications using the various transport protocols that are contained in the family of Z products. So network transport of communications is really key to what we do here at JPS, and a lot of our products utilize these transport methodologies. And besides the quad-core ARM processor, like all products in the Z line, management and configuration is performed using a secure web browser. And remember, each of the modules contains its own integral web services embedded within the hardware. So if you recall, the two-channel interfaces and all the different digital transport protocol interfaces can be provisioned in so many different combinations, but there are 3 native configurations or interface patterns that are user selectable at any time. And these configurations range from a simple 2-channel configuration, as you can see at the left, a cross connection with a single network backhaul, as you can see in the center. And this is probably one of the most versatile configurations, and an independent pass-through configuration at the right, where the channels are segregated and separately are able to backhaul using one of the digital protocols that we mentioned earlier. And if you consider that there are just 3 configurations, you can see that there can be really dozens of sub-configurations when you consider the variations of interface protocols that can be instated. So this is a very low capacity gateway that can find its way into lots of simple standalone and standalone backhaul solutions. And in future applications-based webcasts, we'll see how this little gateway can truly shine in the presence of a Z2 controller or ACU Z1 gateway. So let's take a look at a simple cross-connect configuration, which is really probably the most popular configuration in terms of a standalone application. And one of the most obvious configurations is a cross connection supporting the interoperability between two disparate radio systems. And because of the use of digital signal processors, the radio-centric four-wire interfaces of the RSP-Z2 are purely agnostic and are truly immune to disparities in frequencies, modulation techniques, protocols, even encryption, or even the manufacture of those two radio systems. And as you can see in the diagram at the left, those interfaces do not necessarily have to support land mobile radio systems, but can support also digital transport protocols. And we'll see how we can use those digital interfaces in a moment. You can securely log into the RSP-Z2 by entering the IP address of the gateway into a browser, and you'll be asked to enter your username and password as usual. From this user interface, you'll be able to manage the connections and configure the digital signal processors that support the connected donor radios. And you can check our previous webcasts for examples of land mobile radio configuration interfaces of the RSP-Z2 Dual Channel Gateway. And one of the most common standalone RSP-Z2 applications is a simple cross connection between two disparate radio systems. And remember those agnostic radio interfaces? Well, then when properly set up, it doesn't matter what radio systems are associated to the gateway, as we can see in this example of localized interoperability between a DMR system, a digital system, and an analog conventional system. So these are very dissimilar communication systems in many ways. And simply adding a donor radio to an RSP dual channel gateway, communications interoperability can be easily achieved. And if you recall from previous webcasts, we described how these disparate radio systems interact in terms of control. And remember, when you depress the PTT button on a subscriber unit in the field, as you can see at the left, the interaction between the donor radios and the RSP-Z2 gateway will result in the donor radio keying its transmitter at the right. So if you key the subscriber unit at the left, you are virtually keying the disparate radio, donor radio at the right, regardless of the frequency protocol or modulation technique. And if you properly set up the transmit and receive audio gain for unity and adjust the transmit and receive audio delays, you should have completely transparent interoperability. Because the RSP-Z2 can be set up and left unattended, its configuration will be preserved over repeated power cycles, and even temporary communication. Interoperability can be simple plug-and-play standalone applications. And for those of our viewers that are radio dealers or providers that rent subscriber units for temporary workforces or even events, this would be a perfect application. And a simple plug-and-play gateway allows rented radios, for instance, to operate with existing radio systems at a temporary work site or event. RSP-Z2 Gateway, really an economical appliance that can also be used for protocol migration. And in this example, migrating from a conventional analog system to a DMR system. And I recall 15 years ago, we did something very similar with ACU gateways to migrate from conventional systems to an IDEN system at large manufacturing facilities. And remember, we're protocol agnostic, and this is because of the digital signal processors. Intermodal or interagency communications can be simplified if those agencies, organizations, or businesses use radios that they already own and are comfortable operating. Once an operator is within the coverage area of the supported donor radio, interoperability communications is already in place. And for instance, communications with a prisoner transport between a police department and the sheriff's transport can also achieve interoperability using this simple type of application. Later, we'll look at similar standalone intermodal examples that incorporate a network backhaul of communications between two remote sites, for instance, between factories or warehouses. And for many years, JPS products have been used in many air-to-ground communication products using such things as NXUs, ARAs, and ACU gateways at airfields, both civil and for military applications. And this is a good example of disparate protocols able to safely and reliably share communications. And in this case, amplitude modulated aeronautical radio communications can be shared over FM or digital systems that are commonly used in terrestrial applications. And I'll use this example again to illustrate how our gateways can leverage networks to support aircraft in, for instance, flight following missions. And because of the low power dissipation of the RSP-Z2 Dual Channel Gateway and its ability to operate unattended and maintain its configuration over repeated power cycles, Fireground's applications can be numerous. And one such standalone gateway application is essentially the federation of typical FM conventional simplex Firegrounds communications with a satellite radio backhaul link. Single RSP-Z2 Gateway with a appropriate subscriber unit can be deployed in an apparatus, and it can support an entire strike team. And by incorporating a satellite radio, this becomes truly a pure voice application. And because of the RSP-Z2 has a transmit and audio delay buffer that can store up to 500 milliseconds of audio, SATCOM process delays and free space propagation delays can easily mitigate the loss of the first few syllables or even the words in a transmitted stream. And again, because of the persistent nature of the RSP-Z2 configuration over repeated power cycles, plus the large audio delay buffers and audio dynamic range, the gateway can serve as a simple conventional repeater using subscriber units. And we've done this with other gateways as well. And later, we'll see how we can even backhaul the repeated transmit and receive audio over the network. And because the RSP-Z2 dissipates less than a half an amp, it can be part of a low-cost tactical repeater packet. And if we take a look at the two channels in a CrossConnect configuration or pattern, we're not limited to supporting just land mobile radios, but those channel interfaces can support, again, JPS RoIP, SIP, RTP, even push-to-talk over cellular applications such as ES-Chat and JPS VIA. And this is an example of a radio interface assigned to channel 1 and a digital RTP interface assigned to channel 2. In this application, radio communications can be shared over the RTP link to a console or maybe a voice recording apparatus or any device that has a standard-based RTP interface. So we got analog on the left and digital on the right. And some of you may know we have discontinued our ARA analog radio adapter module, which was a single channel gateway that had an analog radio interface that can accept a donor radio. And it includes a SIP or RTP digital interface. The RSP-Z2 Dual Channel Gateway is really a perfect substitute with the advantages of a better user interface, soft adjustable transmit receive audio levels. And the RSP-Z2 actually costs less than the discontinued ARA1 module, so that's a good thing. Another use case in a simple cross-connect pattern is the ability to establish a back-to-back digital interface. And in this example, we're supporting a remote ACU, a gateway with an RoIP link assigned to channel 1. And channel 2 of the RSP-Z2 Dual Channel Gateway is then supporting an RTP link to a console. And because of the various analog and digital interfaces, you can imagine the many sub-configurations from this simple two-way gateway. So let's talk about another RSP-Z2 configuration pattern, and that would be the cross-connect with a single backhaul. And I think this is one of the most versatile RSP-Z2 configurations in a standalone solution. And as you can see in the center diagram, we're going to maintain the cross connection with the two channels. And remember, those channels do not necessarily need to support radio channels or talk groups. And this configuration includes a single digital backhaul that can support JPS RoIP, RoIP channels, bridge channels, again, SIP and RTP, and various push-to-talk over cellular applications. And in the example below, we're able to share interoperable communications with a dispatch console over a single digital backhaul link. This is what the cross connection with a single backhaul looks from the browser user interface. And again, you can configure the entire system from the menu selection at any time. So back to the Firegrounds interoperability example, where we have two disparate radio systems sharing voice communications, and possibly the P25 subscriber units might be in a possible talk around simplex configuration, obviously because of the isolated nature of the Firegrounds. But the inclusion of SATCOM data terminals, we're able to use one of the backhaul protocols to deliver duplex communications from the firegrounds to a console, possibly using RTP-SIP or even JPS RoIP. And we can also maybe incorporate a voice recording appliance using those same protocols. And by the way, many manufacturers have used the JPS RoIP API and software development kit to directly integrate RoIP into their products. This allows for a pure digital integration with third-party communication products. So those of you who are interested in integration of JPS RoIP into your products, we can connect you with our engineering team and we can discuss similar collaborations. Push-to-talk over cellular systems are really a good example of this type of collaboration with our technology partners, and we'll see a better example of POC a little bit later. You can even link MCC4 or MCC1 multi-channel desktop console directly to the RSP-Z2 over the network. And this particular application utilizes JPS bridge channel protocols without, and this is important, without the need for a Z2 controller. Take a look at our previous product briefing webcast that featured the MCC4 multi-channel desktop console and other products from the Z family of products that support dispatch capabilities. And depending upon your architecture, you may or may not need a controller to support what we call the bridge channels. So as long as the network link can support TCP and has the bandwidth to support JPS RoIP, bridge channels, RTP or SIP, you can have a workable backhaul from RF isolated locations. So LTE, SATCOM, even tactical microwave can be a viable network support mechanism for backhaul out of an isolated situation. And remember, the 500 milliseconds of transmit audio delay buffering can be employed to mitigate those effects of process and propagation delays of those wireless network protocols. And the key to preserving the first syllables or first words of the transmission audio is by using transmit audio buffering within the digital signal processor. So sometimes it appears counterintuitive to use delay to mitigate delay, but that's a key to the preservation of the transmitted audio stream. Returning to our aeronautical application, the RSP-Z2 can support localized interoperability between air and ground communications, but by implementing a single digital backhaul of the RSP-Z2, the presence of a multicast network or even a managed network, remote RSP-Z2 gateways can be set up as a network client and automatically connect to a site where audio can be consolidated. For instance, a dispatch position or even at a NOC. In this configuration, the distributed RSP-Z2 gateway configurations will be persistent over repeated power cycles, and the JPS RoIP client-server association model that we use will ensure that network links are also self-healing. This is a perfect example of autonomous gateways that do not require management. We've seen similar applications used for airborne medical and utilities air operations. So if you take a look at our cross connection with a single backhaul configuration, we might also highlight the digital protocols of all of these interfaces. And you can now imagine really the many combinations of back-to-back disparate digital interfaces that we can create in the RSP-Z2. RSP-Z2 is not just about radios, and we can even link other network-capable devices. So here's an example of a back-to-back digital interface, and specifically the integration of a push-to-talk over cellular talk group with an RTP backhaul to a console. And naturally, we have our simplex or duplex communications in this example. So the back-to-back digital interface is between the JPS RoIP interface supporting a POC system and the dispatch console that has an RTP digital interface. So we can see the back-to-back digital links illustrated in red. And if we want to get tactical, we can pair the RSP-Z2 with an LTE router or a SATCOM terminal with a battery for true isolated communications. And for example, with a 100 watt-hour lithium iron phosphate battery, you can essentially realize runtimes well over 10 hours. Remember, we're dissipating only a half an amp within the gateway itself. So again, the cross connection with a single backhaul has the most interface permutations in any of the three selectable configuration And so natively, you can backhaul two disparate radio talk groups over a single backhaul link, as we can see here. And you can even share a single radio talk group with two different network attached appliances or devices, or you can create a completely digital collaboration between three completely disparate network protocols. And in this example, you might have a collaboration between a connectionless UDP RoIP link and maybe RTP and SIP protocols sharing voice communications at the same time. So RSP-Z2 Dual Channel Gateway is not all about radios and is right at home with lots of different digital protocols. So now let's take a look at the last of the three native configurations of the RSP-Z2, and that would be the independent pass-through. And as you can see in the RSP-Z2 diagram at the right, each of the two channels are no longer interoperating, but are separated and can be assigned completely different digital transport protocols. Again, this is a standalone application which does not rely on servers or controllers. And again, JPS RoIP, JPS bridge channels, RTP SIP, and like the last configuration, we can also support push-to-talk over cellular applications on the backhaul side of the gateway. And to better describe the application of the RSP-Z2 in an independent pass-through configuration, we should talk about a couple of single channel modules JPS offers. And one of those is a single channel NXU2B network extension unit. And this is the latest version, which supersedes the NXU2A and the NXU2 before that. Simply put, the NXUs are used to extend radio coverage by utilizing a network and radio over internet protocol, RoIP. And I encourage you to check out our previous products briefing webcasts on the NXU2B network extension unit to learn more about some of the new features in that network extension unit. And one of the nice things about JPS RoIP is that nearly every product in our catalog has some form of JPS RoIP, even our voters, including all of our multi-channel gateways like our ACU 2000, ACU 5000, ACU Z1. And we've been using JPS RoIP protocol for over 20 years, and it's really our mainstay transport protocol. So it's very common to backhaul radio and telephony communications between remote locations and an interoperable gateway, such as the ACU, using discrete NXU2A network extension units, or even with other remote NXU network extension units. So RoIP is very versatile in this application. Another single channel module is the ARA1, and as we mentioned earlier, is no longer being manufactured. And this is a single channel analog radio adapter that integrates with a donor radio and has a network interface that can be associated to a VoIP telephony enterprise. So once registered with the enterprise, the ARA can be assigned a telephony extension number, just like any normal VoIP telephone. And naturally, the ARA1 can support the RTP protocol without the need of a VoIP enterprise server. The RSP-Z2 in an independent pass-through configuration can be used to substitute any combination of single channel ARA or NXU2 modules into a single package. Remember, the backhaul methods can be dissimilar. Not a very compelling application, but the RSP-Z2 is much more hardware and cost-effective than discrete modules. And the RSP-Z2 by itself is less expensive than a single discontinued ARA1 module. And if your system grows, the RSP-Z2 can always be incorporated into larger distributed architecture and systems when in the presence of a Z2 controller or the ACU Z1. So your investment is essentially future-proof. Another interesting standalone application is the linking of communications between two different locations utilizing two different radio talk groups. Again, this is an intermodal application, but it lends itself well to other applications where personnel work at two different locations, but still require the use of their radios. In this example, a worker A is able to communicate as usual at his or her home facility, but when making a delivery or working from a remote site, the RSP-Z2 in independent pass-through mode will allow worker A to communicate with his or her home facility from the remote facility by virtue of the two RSP-Z2 gateways in a peer-to-peer association over the network. And again, this is an autonomous configuration. Again, we don't use servers or controllers to maintain the RoIP link between these two remote sites. So conversely, a worker can travel and work at a other remote facility and still have the ability to communicate back to his home facility, just like worker A. And implicit feature of this type of application is that the remote user, worker A, which is at the right, can switch to a radio talk group that allows them to not only work at the remote site, but also allows he or she to communicate directly on that system. And if you can create a multicast network, you can even link several remote sites together to create some interesting architecture. And finally, we discussed all the backhaul methods, regardless of whether the RSP-Z2 Gateway is configured as cross connection with a single backhaul or even as an independent pass-through. But where the RSP-Z2 truly shines is when it's in the presence of a Z2 controller or an ACU Z1 gateway. So in the future, we'll have application-based webcasts of RSP-Z2 gateways in larger distributed communications systems where we'll highlight the dynamic linking of our JPS RoIP and JPS bridge channels to support many distributed gateways. So even though the RSP-Z2 Dual Channel Gateway is considered a low capacity gateway with only 2 channels, and hopefully you can see that with the use of user selectable configurations or patterns and a multitude of analog and digital interfaces coupled with radio-centric digital signal processors, complex communication problems can be solved with a simple standalone configuration. And with a network, the possibilities are endless when combined with an LTE SATCOM network or even a tactical microwave. And remember, the RSP-Z2 in these applications can operate in isolation without the need to be supported by a server or a controller. And we'll look at those types of applications in future webcasts. And remember, configurations are persistent, and even the RoIP links are self-healing over repeated power cycles, or even when the networks are intermittent. So I'd like to thank all of you again for joining our webcast today. And if you need more information regarding the RSP-Z2 Dual Channel Gateway or any of the products in the Z product line, you can always call us directly or visit our website at jpsinterop.com. And Carol, do you have something you want to close with?
Again, thank you for joining us today. Any other questions, please let us know.